All right, everyone, how are you? Well, today we're going to be discussing the clotting cascade, and I'm stuck here spending my Friday nights doing this. So you guys better make this worth it. All right, so let's start. The clotting cascade, what is it? What are some of the things that we have to do? Well, let's just make a list, and we need 4 things as part of our entire blood coagulation pathway, right? So, number 1 is that we have to vasodilate. And when we vasodilate, we release certain substances, certain chemicals. So 1, vasodilation, and we release serotonin and endothelin. Next is we form the platelet plug, right? Once we have bleeding, we have to form the platelet plug. And for that, we need some things from the platelet membrane, right? There are certain glycoproteins that we have to need. Those will be your GP1A, GP1B, your GP2B, 3A complexes. You need all of those, right? Now, each of this is very important. It binds to certain things, and you have to know which glycoprotein, what it binds to, right? So your GP1A is very important. It binds to collagen. That's the main thing. GP1A, collagen. What about our GP1B? Well, GP1B binds to our von Willebrand factor. So in short, it's going to be VWF. And GP2B3A binds to fibrinogen. So it's very important that you know what each thing binds to, and if one of these things are missing, then it leads to certain diseases, and we will discuss that later on, right? But the main thing is that your GP2B3A binds to fibrinogen. That's the main thing. Now, what's our third step? Once we have the platelet plug formed, what do we do next? Well, we try to make the soft clot and convert that into the hard clot, right? And to do that, we have to make fibrinogen into fibrin, and that's the ultimate goal. That's basically it. And our 4th step is just going to be to dissociate the clot, right? Just to break it down. Out of all of this, our 3rd step is the most important step, all right? All of those clotting factors, your 9, 10, whatever, right? All of this adds up, and the entire purpose is just to convert fibrinogen into fibrin. That's the real purpose of it, nothing else. And we're going to look at how this is going to happen, all right? So I like to work backwards. I want to know what I have to do at the end, and what do I need to reach that end. So what is my end? What's my end goal? Well, that is to convert fibrinogen into fibrin, right? But to do this, what do I need? What do I need? I need thrombin. Well, that's the next dilemma. Is thrombin always in the active form? No, it's in the form of your prothrombin. So you see how this is going? We need components to activate other components. Our end goal is to convert fibrinogen into fibrin, but for that we need thrombin. And let's just make everything easier. Fibrin is going to be our factor 1. Fibrinogen is factor 1. Fibrin is factor 1A. Thrombin is factor 2A. It's the activated form. So, and prothrombin is just factor 2. Now, to convert prothrombin into thrombin, that's also a dilemma. And what we need to do this is our prothrombin complex. And that's where your factor 10A comes from, right? So this is the grand scheme of things. Fibrinogen to fibrin, for that we need thrombin, but thrombin is going to be in its inactive form. We have to activate that, and we need the prothrombin complex. And the main component of the complex is going to be your factor 10A. So almost clotting cascades, right? You have there's so many ways we can get 10A. We have our extrinsic pathway and our intrinsic pathway, and both lead to activate 10A. So now we're going to discuss the clotting cascade in a bit more detail, all right? So we have our intrinsic, we have our extrinsic, and the end goal for both of them is to make your factor 10A. Right? That's all we need. So let's start with the extrinsic. What are the components of our extrinsic? We have tissue factor, which is your factor 3. And we have factor 7, right? So all of them are going to be in the activated form. So we're going to have 7A. And basically, these are the two things that you need. You need factor 3 and 7A, or 3A as well, to make 10A. And the easy thing is 3 plus 7 equals 10. So you know these two factors will just make factor 10A from the extrinsic. And we also need one important ion, and that ion is our calcium. Right? That's simple as that. Extrinsic, tissue factor 3, and then factor 7. 3 plus 7 equals 10. We have our 10A from the extrinsic. Now let's look at our intrinsic. Intrinsic, we start off with our factor 12A. That is going to activate factor 11 to become 11A. And do we have factor 10? Oh, factor 10 is right over here. So what's the next factor that comes in mind? Factor 9. A, and then factor 8. So we need these two, factor 9 and 8, to make factor 10, right? So here extrinsic, it was 7 plus 3 equals 10. Well, here in the intrinsic, it's going to be, well, if we count, right, 1, 2, 3, 4 is going to be 8, 9, 10. So 8, 9, and 10. That's the easy way. So factor 8 and 9, complex to make factor 10A, but also they also need a very important ion, and that's going to be your calcium. So it needs calcium. And it needs a fourth thing. It needs phospholipids from the platelet membrane. So phospholipids, PL. And that's about it. So your extrinsic, 3, 7 equals 10. Your extrinsic, 8, 9 will make 10. You need calcium, and you need your phospholipids from your platelets. Once you have factor 10A, then you have to make your prothrombin complex, right? So what's thrombin again? Thrombin is our factor 2, 2A. So we have to go from 10 to 2A. That's our main goal, right? So if we just do simple division, what can we divide 10 by to get 2? That's 5. Simple math. So we need factor 5A. Simple as that, right? So in this case, 10 divided by 5 equals 2. Factor 10A with factor 5A will make factor 2A. And the same thing that you have to understand is we also need our calcium. And we also need our phospholipid from the platelet membrane. So these 4 things are going to be your prothrombin complex, right? And these 4, 8, 9, calcium, and phospholipid are going to activate 10A. Simple as that. All right? 3 plus 7, 10, 8, 9, 10, and then 10 divided by 5 equals 2. That's our clotting cascade. Now, 2A is going to be our thrombin. Thrombin converts fibrinogen into fibrin, right? So your 1 becomes 1A, and your 2A, which is your thrombin, is going to do that. Simple as that. This is called our soft clot. So they might ask you a question, well, okay, once you have the soft clot formed, which factor is going to come in and make the soft clot into the hard clot? Well, that factor is going to be factor 13A. Okay, so to convert 1A soft into your hard, we need factor 13A. And what's so special about 13A? They might even ask you that. The main thing about 13A is it has transglutaminase activity. That's the main thing about this factor 13A. Alright? So 13A has transglutaminase activity, so you convert the 1A soft clot into the 1A hard clot. And this is all your clotting cascade. All right, now let's go into our diseases and our testings, right? Your clotting time, bleeding time, and all of those disorders. It's really not that bad. It's actually pretty simple. So you have certain things, right? You have your bleeding time, you have clotting time, you have PT, APTT. Well, what are all of those? So first thing, bleeding time. Well, bleeding time is the time needed to make the platelet plug, right? And what do we need for the platelet plug? We need our GP1A, 1B, and our GP2B3A, right? And if you have defect in any of those, your bleeding time will increase. So if you have a GP1B deficiency, which disease could you get? You could end up with B for Bernard-Soulier. Right? Bernard-Soulier. GP2B3A is going to be a huge name, thrombocytopenia of Glanzmann and Naegeli, right? So, just for short, Glanzmann. And Naegeli. Simple as that. Well, our von Willebrand factor is also part of the platelet plug. So if you have a defect in that, that will also increase your bleeding time. But Von Willebrand is a very special case. So this is part of the platelet plug. So we know for sure that if we have a defect in this, our bleeding time will increase. But what about our clotting time, right? What about our clotting time? Will that go up or no? Clotting time, whoa. Well, because a defect in the clotting time means that you either have a defect in your extrinsic pathway or your intrinsic pathway, and then you have to know which factor is missing, right? So, intrinsic, extrinsic. Intrinsic is going to be your APTT, right? Remember what Opadia said, table tennis you play inside and then regular tennis you play outside? So intrinsic, APTT. Extrinsic, PT. The main thing about von Willebrand factor is that it carries factor 8 with it. That's the main thing. Okay, so with this you have factor 8. Factor 8, that's the main thing. So if you have von Willebrand deficiency, you also have factor 8 deficiency. So which pathway is factor 8 part of? Intrinsic or extrinsic? And that's going to be your intrinsic. So your APTT will also go up and your PT will be normal. So that's the key thing. So von Willebrand factor deficiency, bleeding time goes up, so does your APTT. All right, so we good with this so far? These are going to be your just bleeding time disorders. This is going to be bleeding time and your clotting time, but specifically your APTT. Now let's discuss hemophilia. Hemophilia is actually not that bad. So whenever we say hemophilia, hemophilia is bleeding of the joints, right? You get bleeding in your elbows, you get bleeding in your knees. That's it. So if you see that in a question stem, most likely it's going to be hemophilia. And you have two types. You have type A and type B. And you have to know that which factor is associated with which. A is going to be factor 8. B is going to be factor 9, right? So 8 comes before B, 8 comes before 9. Easy as that. And what's the common thing between factor 8 and factor 9? Well, both are part of your intrinsic pathway. So if you have hemophilia, everything else will be normal. Bleeding time is going to be normal. Your clotting time is going to go up, but more specifically, will it be your prothrombin time, PT, or just your APTT? Well, these two are part of the intrinsic, so our APTT will increase, and that's the only thing you're going to see increased. So if they say, hey, a patient comes in bleeding in the joints, right? So what would you find in his blood test, right? So you're going to see that APTT will be the only thing that's high. And this is basically it. Oh, and one more thing that I have to mention about vitamin K, right? So vitamin K we need. We need the vitamin K to activate our factor 2, 7, 9, and 10. Also protein C and S. Yeah, sorry it's a lot, but it's simple at least, right? Vitamin K, factor 2, two, 7, 9, 10, C and S, right? So these two are gonna make the clotting cascade, all of these. C and S. S is the cofactor for protein C. And the job of C is to inhibit complex 5A and 8A. So basically, protein C and S inhibit the clotting cascade. And why do we need to do that? Why do we have to inhibit that? Well, for example, if you have excessive clotting, right? You have a bleeding, an injury, you clot, and if you form too many clots, well, one of the clots could go into the brain and cause a stroke. So you don't want that at all. Okay? So you have to inhibit that, and protein C does that. S is the cofactor, and vitamin K activates via gamma carboxylation. Right? This is how these factors are activated. You have gamma carboxylation. You need vitamin K, and you can give warfarin to inhibit that effect, because warfarin is an analog of vitamin K and it can inhibit gamma carboxylation. So just keep that in mind. Warfarin inhibits gamma carboxylation, and we're done. That's about it.